Hey guys, welcome back to AlgoYogi. Now we are doing array and hashing series, and our next problem in the list is unique email addresses. So let's go to LeetCode. It's a lengthy description, but let's quickly go through it, some of it. Every valid email consists of a local email and a domain name separated by @sign. Besides lowercase letters, the email may contain period or plus sign. For example, alice@leetcode.com, Alice is the local name and the leetcode.com is the domain name. If you add period, so I'm just gonna switch the view and just tell you guys what's going on. We are given an array of a lot of email addresses. Now an email address consists of a local name and a domain name. Here if you see, and these two are separated by @. So it would be better to write @ here, right? @. Now this right here is the local name, and if you see in the example, this is the local name, and this right here is the domain name in our email. Now we will be given an array of email addresses, and what the problem is saying that a lot of email addresses that are same because there are certain rules around email addresses. Let's say this email could be simplified to they are saying that one of the rule is that if you see a period in local name is ignored. That's rule number one. So period in local names is ignored. Second rule is anything after plus sign is also ignored. So if we apply both these rules, to this example that we have taken, so what we'll do is we can simplify this to Algo, period is ignored, Yogi, plus after plus everything is going to be ignored. So this thing right here is going to be ignored. Whenever you are seeing a plus, you will be ignoring it. And then @gmail.com. So basically what's happening is these two rules only apply to local name, and then you just create or simplify the original emails. So what we'll do is the problem is asking us to return the number of unique email addresses in the array that they have given us. So what we are really going to do is go through email by email and then simplify that email and add it to your set. So at the end of once you're done processing all the emails, then you'll have a set that has unique email addresses, and then you can return the count of those email addresses. So that's what we will be doing, and it will take us the time complexity of big of n, and space complexity is also going to be big of n because of the set. And here you can also say that this could be n into L, because we will be performing L is the longest email. The reason is we'll be performing certain little operations like split, and although these are inbuilt functions, however they do have their own time complexity, right? So we do seem to ignore it, but you can talk about it if you want to go in detail, right? So splitting, adding two strings together, so those are implicit time complexity. Usually it's not considered, but you can talk about it if you want to sound smarter. So it's a simple problem. I'm sure you might have already written the solution. So what we are going to do is we'll be creating a result set. It's going to be a simple set. Then we're going to go through all the email in emails. Let's split local name and domain name. So we'll do this email dot split, and we are splitting it by at the rate. So this will split it at either just one single at the rate or like the first at the rate, right? It will split it into two. Now there are certain rules about local name, so we're going to change the local name. So I'll say new local name is going to be this local name dot split. We are splitting at the plus sign because we are gonna ignore everything after the plus sign. Let's take the first part of this split, and then we will replace what are we replacing? The period, and what we are appending at place. What are we replacing it with? Nothing, just empty string. We are ignoring these periods. Now we will add this new email address that we are going to create to our result set. So result.append or add in this case. So we'll do is new local name plus the domain name. Domain name will remain same, but do not forget that we actually need to add the rate in between, right? And then finally return the length of this result. All right, so let's zoom out, run it on the example cases. Awesome, let's submit. Crazy. Okay, so time complexity is going to be big of n, given that we are kind of ignoring all these operations and saying that these are happening in constant time. But like, remember, split and replace, etc., they themselves take big of n time complexity if you go into these inbuilt functions, although like we seem to ignore it. And space complexity is going to be big of n as well, because you're storing it into the set. Can you do better? Well, I don't think so. If you think you can, please do it. It's a really old popular problem, but I feel it's not going to be possible because you have to create a set so that you can collect the unique addresses, or there is no other way of like doing it in linear time, and also counting things like you have not if you don't have a way of like remembering if you have seen something before. Well, let's go back to AlgoYogi. My day is solved. See you guys later in the next problem.